Here we go. We're going to do a warm-up. We're going to talk about some homework problems. I'll tell you right now that I will not be giving you credit for just random numbers on your page, okay? As an example, I showed what was fairly minimal work, okay? I showed what was fairly minimal work, and that's how much work I have for 100. Okay? So, if you just have an answer in a box, you're not getting it, right? Fairly minimal, that's 98. Okay? Again, 101, like squeezed in there. You need to have work on there. Okay? So, I'm just telling you right now because I don't want you giving me any weird sob stories about, really? Because you're right. I'll make a sign. Let me tell you the same thing I told you day one, and I've told you every day since. The rudest thing you can do is talk while I'm talking. Don't do it. I don't even talk to you for that long. Okay. Make sure you have all the work. Lots of work. And let's get rolling on our warm-up. I'm getting fancy. Trying to, at least. We'll see if I can do it. I believe in myself. I almost had it. Just pretend. That's what notation's for. Okay, sorry, weird shape. There it is. I would like you to please find the perimeter of said shape. Boom. Okay. You'll put it back. Hint. You're going to need to use the knowledge about special right triangles that we have been working on for that one. How about homework 97 to 102, please? You need to use properties of both, which is why I love it, the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. Okay? So we're going to have to use both, which is just fantastic. We talked a lot yesterday about the 30, 60, 90 right triangle. Words? Okay? And we talked about this idea of it being the pivot point. Now again, I'm going to say what I told you yesterday. If you're only getting caught memorizing like that the hypotenuse is twice the short leg, then you're going to end up getting mixed up at some point. A better idea would be to say, like, each time for myself, each time I see the 30, 60, 90, I picture it as an equilateral triangle. That's a true story. I really, truly do. Because I have a hard time remembering, like, which side gets the 2 and the root 3. It's hard for me to remember. So each time I go ahead and I picture it as the full triangle. And that helps me remember, oh, yeah. So this short leg, that's half of the original side. And that means my hypotenuse right here is going to be double the short leg. Right? So to get from the short leg to the hypotenuse, I would need to double that. Right? Instead of 6, the hypotenuse would be 12 times 2, and I would have 12 feet for my hypotenuse. Of course, sorry, we didn't necessarily even need the hypotenuse, but I'm just writing it in to make sure we're oriented. Okay? The other piece then, and usually for me, once I remember which one's double, I know the other one's square root 3. Okay? Once I know which one's double, I know that the other one's square root 3. Or you wouldn't ever have to memorize that because you could always do Pythagorean theorem right here. Okay, from right here, you could do some Pythagorean theorem, and you could find out that height there, that missing side. And again, the same property of the missing side says there, it's times the square root of 3. So this side would be 6 root 3 feet. Okay, so times 2 times root 3. And then you'll notice that this other triangle, and we want the perimeter, so I need all the sides. This other triangle is a 45, 45, 90 right triangle. And we should, I don't know, if you don't recall, you'd flip back to your notes. What? Oh boy. Is it for me? Shh, don't tell her. Okay, there's the 45, 45, 90. Reminder, maybe I look back at my notes. Maybe I went like this because if I haven't figured it out yet, it's in my notebook, my workbook. In the back of your workbook, everyone turn there now if you haven't seen this yet. In the back of your workbook, at the bottom, oh snap! Look, you don't even have to memorize it. Okay? Okay? Because I could turn those triangles any which way, and they would, it just depends. I just blinded myself with that one. Okay, the important thing to keep in mind, and Cody kind of said, because they're kind of oriented weird, it's important to make sure we can have that like rotation in our head. Right? Recognizing like the short leg is always the shortest one, the hypotenuse is always opposite 90, all that kind of good stuff, Toby. Shh. So, again here we see on the 45, 45, 90 triangle, the legs are the same, and to get to the hypotenuse, I multiply by the square root of 2. In fact, if this notation helps you, I would add that to my workbook. Okay? If that notation helps you, then you should maybe fill this in too. That say like, okay, this means I'm multiplying by 2. To go backwards, I divide by 2 or whatever. This would be a really good spot for you to add in some things that help you remember what you're doing. Okay? All right, back to it. What I was saying is that if the hypotenuse is 12, to go backwards on the 45, 45, 90, to go backwards, what do? Don't say it all at once, I'll get overwhelmed. Divide by what? Boom. Divide by the square root of 2. I could write it as 12 over root 2, or I can write it as a decimal, which is 8.49. I rounded, of course. Rounded. 8.48. That 5 kicks the 8 to a 9. So, if that's 8.49, then this is 8.49. So my perimeter would be all of it, everything, except for that middle piece. Like, don't add the 12, because that's not part of the perimeter. The perimeter is in pink, and so the perimeter would be 6 plus 6 root 3 plus 8.49 plus 8.49. I don't know what 6 root 3 is, but I can go ahead and just type that stuff into my calculator. So I'd have 6 plus 6 root 3 plus 8.49 plus 8.49. Type it all in. Notice I just wrote the 6 root 3 as 6 root 3. And 33.37. Feet would be the answer. Not too bad. Okay. Good problem. Great problem. I like that kind of problem. Hint, hint.
What?
All right. So now I'm going to give you guys 5, maybe 6. I would like some focused conversation around volume. Okay? What's going to end up happening next week? We're done with Unit 2 next week. So like today, I'm just telling you, today we're practicing volume. There was some volume on your homework. You need to take the conversations seriously. right? And that you really today, by the end of today, I really need you a lot more comfortable with volume. Okay, that's what we're spending most of our day on. So, right now you had 5 problems in your homework that were all volume related. Make sure you take 5, actually probably 6 minutes to have focused conversations about each one. Where you're explaining what you did, your partner's explaining what they did, and maybe as a team you're coming up with, oh, this is where we both went wrong. Ethan, nice try. It's just so much, my dear goodness. Let's not ever do that, ever again. Okay, 6 minutes. Please make sure your conversations are focused and centered around mathematics. Notice my units. Same as it says up here. Square feet versus cubic feet. Square feet. Area is a 2-dimensional measurement. Same as surface area. Surface area is still a 2-dimensional measurement, even though we normally do it on 3-dimensional objects. Okay, surface area is a 2-dimensional measurement. Volume, now we're talking about 3D. Okay, volume is the space inside. And if we're talking about 3 dimensions or cubic dimensions, okay, making sure our units now are cubic feet. Because yes, if I ask you a volume question and you give me your answer in terms of square footage, you are wrong. Right? Talking about that precision piece. Making sure we're being precise when we talk about our units. That cubic feet are very different from square feet. So if you need to go ahead and make again, maybe you need to make that note on the inside of your workbook. Maybe you need to make a little note to self on the inside that says cubic feet for volume, square feet for area, so it's not something that you get mixed up. Okay? Sorry. Okay. That being said, which ones do we have questions on?
Oh, igloo.
What's around? Huh? 102? 99? Anyone want to second either of those? $99, 102, 100. What else? All of them. Don't say 21, I'll kill you. All right.
That's a great teacher.
What? Huh? All right. Here's what's going to happen. Now, I'll remind you, when I'm talking about the problems, I'm going to go real fast.
Cool.
The idea not being that I'm teaching this to you for the first time. Bye. The idea being that you're checking what you did. You should have already had a conversation about what you did. You should have a good understanding of what you did. So that as I give a real quick explanation, you can pinpoint the part you missed. That's the goal. I'm not teaching you about it right now. Okay, I just need you to be clear. Like, this is not me teaching you. Showing you real quick, like. Okay, this is not a teaching moment, per se. Okay, so, 98. You have 2 pieces to this little house. Okay, there's the bottom piece of the house. That's 10 by 33 by 6. But then you also have the top piece of the house. It's close. Okay? And the top piece of the house, we know, this is also going to be that same 10. And when we're talking about the height there, okay, it told you the overall height was 9 feet. And it tells you that the height of this wall is 6 feet. So then leaving this height of the roof to be what? 3 feet, okay? So that would be 3 feet. These are all feet, 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 feet. So if I'm trying to find the volume of the rectangular shape, length times width times height, it's going to be 10 times 33 times 6. So that your volume is 1,980 cubic feet. Cubic feet. Whoa, I almost had it. Cut. Cubic feet. It got crazy right there. Jeez. It's driving me wild. Okay. Now, here, this triangular prism, I need to find the area of the base. What, if it's a triangular prism, what shape is the base? Triangle, right? I need to find the area of this triangle, and I'm thinking about taking the area of that triangle, and I'm going to multiply it all along here as the distance, so that that would fill in my volume. Okay, so if I'm trying to find the area of this triangle, area of a triangle is base times height divided by 2. Okay, base times height divided by 2 for the area of the triangle. The volume here is going to be the base area times the height. The base area is base times height divided by 2. And we know the length of this thing is, or the height, if I tipped it upside down, is 33 feet. 10 times 3 is 30 divided by 2 is 15 times 33, which gives you 495 cubic feet. So that your total volume, the sum of those two, is going to be 2475. Right, when I add this guy, these two up. Okay, there's 98. We're going to talk about 99 as well. Pay particular attention to 99. 99 is the first problem you're seeing of a really big idea. Okay, the same big idea that we did when we compared side ratios and area ratios, we can also compare side ratios and volume ratios. And that's what 99 is getting at. Okay, from one pool to the other, how much bigger did he make it? From one pool to the other, if I was talking about the dimensions, how much bigger did he make it?
2 times.
Twice as big. Okay? He makes 3 feet by 1 foot, and then he doubles each of those dimensions to make it 6 feet by 2 feet. And then the question was, how much longer is it going to take him to fill it? In other words, how many times bigger is this pool than the first pool? So I'm going to find the volume of both. For a cylinder, or for any prism, it's going to be the area of the base times the height. We know the area of the base is a circle. So here, if I'm trying to find the base area times the height, the base area is going to be pi times 3 squared times the height of 1 foot. Gives me 9 times pi times 1. I wrote that down somewhere. No, I didn't. Which is going to be 28.27 cubic feet for the first one. Same thing for the second one. The base area times the height. The base area is a circle. Area of a circle is pi times its radius squared times the height. 6 squared is 36 times 2 is 72 pi. Which is 226. Okay. I want to look at these two numbers though. You might be able to see, you could divide those two, but I want to look at these two. How many times bigger is 72 pi than 9 pi? 8. Who can tell me why that 8 makes sense? Actually, who can tell the class why that 8 makes sense? Because I already know. I don't know. Okay. Tell them, not me.
So basically, when you multiply the dimensions, multiplication works like completely evenly. So it multiplied the height by 2, and then it multiplied the radius by 2. Since the radius is squared, it basically multiplied another dimension by 2. So it was 3 2s and 2 times 2 is 4, and then 2 times 4 is 8, and so it multiplied the whole thing by 8.
Did anyone get what he said?
No. I heard 2 times 2 times 2 is 8. That's not it.
Yeah, you should hear that 2 times 2 times 2 is 8. That's an important one to hear. 2 times 2 times 2 is 8. That's true. Hayden, adding?
9 times 8 is 72.
It's very helpful, Hayden, but that's not the way you want to learn.
Hayden, who cares?
Wait, could I go ahead
Sorry.
and explain?
Shh, no, listen. It's okay if you don't know what I'm talking about right now.
Did I explain it good though?
No. Well, sort of.
Proof's in the pudding. Sorry. Cameron.
Surface area ratio standard feet. Square therefore volume is cubed.
I think that was succinct. Say that again.
Surface area is squared compared to the ratios of side length. So volume is cubed.
Okay, listen. No. Don't say what. You can ask a constructive question. One. Okay? But here's the deal. Right? What's the scale factor right here? From one to the next. From the pool, the dimensions of the pools. From the dimensions of the pools, it's 2. Right? We got twice as big. If we were talking about surface area now, right? Or similar shapes. If I made the sides twice as big, what happens to the area? Marcus? Why 4? Okay, so check this out. What if I made the sides 3 times as big? What would happen to the area? We're not sure. Okay. Don't just say random things, Devin. Irritating. Okay, we'll get back to it then. Because we are not ready for that. I do want to talk about the other parts.
So what should you let me write it down? I could, if you let me write
Bella,
it down,
I would encourage you to stop while you're ahead. Okay. We'll talk about it later. You'll see it again. It's okay. We're going to talk about those other problems. There's one shape we haven't talked about yet, and it was in your homework. What shape was in your homework that we didn't talk about? Sphere.
Sphere. I was going to say that. I said sphere.
How to draw a sphere, if you don't know. Start with a circle. In the middle of the circle, if you don't know how to draw a sphere, in the middle of the circle you draw like a belt. I don't know. Pretend you're drawing that circle around the sphere. And try and make it even. There's a sphere. You open the door, please. Spheres, like all circular objects, have a radius. And we've already talked about the surface area of the sphere. The surface area of the sphere is going to be I don't know how to way to write it. I'll show you that way. 4 times pi times r squared
Yeah.
is the surface area of the sphere. Oh, I know. I just tried to write it differently. You can write 4r squared times pi. And then the volume of a sphere, and this one's strange. Just telling you that right now. Is 4/3 times pi times r cubed for the volume of the sphere. Now again, Soriana asked a good question. How do I memorize all this stuff? Well, I've done it a bunch. But am I asking you to memorize this? I am?
No.
Oh boy, that's why I gave you a formula sheet. And we write it down. And I let you use these on the test because I'm asking you to memorize it. I'm not asking you to memorize it at all. I'm asking you to know how to use it for sure. Okay, the sphere is kind of strange. Okay, you're not going to be able to build back where that 4/3 comes from on a sphere. You're just not. Okay, versus prisms, on the other hand, you can build, there's no real formula for prisms, right? It's the base area, there's a general framework of the base area times the height, but depending what that base is, you're going to be having different formulas. Okay? This is the one for spheres, though, so that you have it. And now what I need you to do on your paper is make three columns. Fairly even columns. Columns go up and down. Make three columns. Like we're going to make a little long table. In the first column, shape name. In the second column, please write drawing with dimensions. And in the third column, write volume. Without talking, I need each person to take one shape from the box. Without talking, each person take one shape from the box. Whoa, without talking. We are going to be finding the volume of these shapes. I'll remind you that you found the surface area of these shapes a bit ago. Now, when we found the surface area of these shapes, there were two things, quite frankly, that you guys were not very good at. And I hope that you're slowly getting better at this. But today is going to be probably the last time I use my time, bless you, to explain how to measure. Some of you are still not sure. Like learning new things, it's okay if you don't instantly get it. But this is a skill that it's not okay to never get. Okay, you need to make sure that you have it. So here's what we're going to do. One last time, I'm going to draw an inch up here broken down into 16ths. Because you are going to be measuring to the nearest 16th. Starting next week-ish, or the week after, but before winter break for sure, we are going to start working on our project. The house. It is not going to be okay at that point. Like it's getting, feeling kind today for some reason. Okay? You don't even know. Don't even go there. So this is going to be the last time I talk about it. When we start building, you all have to know how to read a ruler. And I would so much rather you ask now. When is not a good time to ask, and when me and Mr. Hrishu might just flip our lid, is if you were trying to cut a piece of wood and you go, I don't know how to do this, can you help me? That is not the time to ask one of us. Maybe ask a peer because we'll lose our minds. A really good time would still be before after school. Now would be fine. Now to say, can you help me a little bit? Okay? You have to know. So let's just break it down though. Break it down. Okay. That's an inch. What's that? You guys, see? Most of us are good at like a whole inch or a half inch. If you need help finding the nearest whole inch, I don't know. I've got nothing on that. Okay, that's half. And we're pretty good at halves. And you know what else you guys are pretty good at is this one.
Quarters.
Yeah. We're good at quarters. And it goes like this, right? 1 quarter, 2 quarters. And what's 2 quarters reduced to? A half, right? We all have talked about nice, beautiful, proper fractions. So that then this one would be 3/4. And of course, 4/4 is a whole. Yay, fractions, okay? Now I can go one further, right? If I break a fourth into half of a fourth, yeah, you get an 1/8. And this would be 1/8, 2/8, which of course simplifies back to a fourth. This guy would be 3/8. 4/8 would be a half, simplifies. 5/8. 6/8 simplifies. 7/8. And 8/8 is a whole. Yay. Okay?
16th.
And then, of course, we get down to the 16ths. And again, the 16ths are also going to line up with all these lines that are already on there. It's just that at those numbers, they simplify to an easier fraction. Okay? So here, of course, we have 1/16, 2/16, 3/16, 4, 5/16, 7/16. A good marker to know is that halfway is 8/16 because 8 is half of 16. That's a good one to know. I sometimes need to count up from 8 still. Like if my measurement was right here, I would have to go, okay, this is 8, 9, 10, 11. That's what I do. Okay, I still have to do that. It's okay. 11, that one was 9. 11, 12, 13 16ths. Am I off? Nope. 14, 15 16ths, and yay, 16 16ths is a whole. Yay. Okay? Making sure we are measuring right now to the nearest 16th of an inch. Here's what's going to happen. In a blank page in your notebook. A blank page in your notebook. No talking. I forgot this part. I got ahead of myself because I got all excited. Nuevo página. Is that good?
On your smile, I can tell.
Yeah, thank you. She's just trying to get brownie points, though. 3 columns. New page in your notebook. You can do it at the bottom if you have a lot of space, but make it a chart. Un chart.
Such accurate Spanish. 10 out of 10.
You guys don't know my life. God.
Okay, what language are you going to try to butcher next?
I'm not trying to butcher it. I literally do like A comes into my head as uns like all the time. And sometimes I just say it out loud.
How do you say cup?
I don't say cup. How do you say cup? Okay. I do know cup, but it's not in my head right now. Okay, name. I guess of the shape. Or how about this? I got this. Shape name. Drawing. Cone dimensions. That was for you.
Oh, I'm trying to remember this.
Drawing with dimensions. Example, like if I was drawing this, right? If I was drawing this thing, this is a tetrahedra, but you don't have one of those. Tetrahedra. And I would draw it like this, except I can't really. I would draw it, and I would label it like, oh, this is 3 inches, and this here is 2.5 inches. Okay? So I would label it. Examples are nice. And then, oh, you have a pyramid. And then this is going to be the volume, where I'm then finding the volume of said shape. Okay? What I want you to do right now, you have your shape. If you need to trade it in, I'm just going to warn you, the cone is the most difficult. Okay? Hold up. You have right now 3 minutes to measure and find the volume of your shape. Ready, set, go. How do I put 5/8? Right? To a decimal. Muy importante. It's coming out today. I said it fine, okay? You know what? Shut up. 5 divided by 8. Please make sure you are entering, when you're finding your volume, you're using decimals. Don't be trying to put like 4 and 5 weird stuff. So that this would be 4 point, anyone? 675? Oh, did you hear what I said? 75, I was wrong. Okay, proceed. You have another minute.